Alright, so 7.1 in Chapter 7, which is factoring by greatest common factor, which I meant to write GCF now that I look at it. So, when we refer to factoring, what we're really talking about is finding all the numbers that a number can be divided by. If I look at the number 20, if I factor this, the first thing I'm going to start with is 1 and 20. Those two, 20 can be divided by 1, gives us 20. 20 can be divided by 20, which gives us 1. Then I move on to 2. 20 divided by 2. If I move on to 20 divided by 4 gives me 5, and 20 divided by 5 gives me 4. So once these two numbers switch places, so if I keep going up 1, 2, 3, 4, 5, the next one I'm going to land on is 5 and 4, which I already have that pair. So that tells me that I have found all of my factors. Now if I look at the number 12, and I factor that, I have 1 and 12, 2, 12 divided by 2 is 6, 3, 12 divided by 3 is 4, and then I'm back up to 4, which 12 divided by 4 would give me 3. So I know I have all my factors. When I refer to the greatest common factor, if I'm looking at, I'm going to put a box around these so you know those are the main ones. If I'm looking for the factor between 20 and 12, the biggest number that you, and in this particular case, the largest number, both of those can be divided by. So that's what we're referring to when we say greatest common factor. So what I want to move to is our section worksheet. We're going to do a couple of these for the video. I'm going to zoom in just a tad. All right. So when we're talking about factoring polynomials, we're basically looking at undistributing. So I'll show you that part afterwards. So the first thing I need to do is figure out the greatest common factor between 12 and 4. I factored 12, and if I look at my list there, 4 was one of the factors. So my greatest common factor between these two is taking that 4 and putting it out. Also looking at my x's. I have x squared and I have x to the 4th. So my x's out of that is 2. So I'm going to take out x squared as well. What I mean by undistribute that is I'm going to divide both of those things by 4x squared. That's a greatest common factor. And then I'm going to put that 4x squared here. Then what I have left after I do that is 12 divided by 4, which gives me 3. X squared divided by x squared gives me 1. There's no x's with that 3. And then bring down that minus. 4 divided by 4 is 1. And x to the 4th divided by x to the 2nd, I subtract exponents, so I have x to the 2nd. So, and here's my check on this. If I have 4x squared times 3 minus x squared, right, and I were to distribute that, I have 4x squared times 3, which is 12x squared, and 4 squared times negative x squared gives me negative 4x to the 4th, which is what I started with up here. So this is the factored form of my polynomial. And that is my answer. I have factored out a greatest common factor, and that's the most that I can do with that because there's nothing that I can factor inside the parentheses, but we'll get to that later. So if I look at number 3, if I just slide to the right on my paper, I now have three different terms. I have 6, 4, and 2. My factors of 6 are 1 and 6, 2 and 3, and then I'm back to 3 and 2. My factors of 4 are 1 and 4, 2 and 2. My factors of 2 are simply 1 and 2. So, my greatest common factor, the biggest number that I can divide out of all three of those, is 2. I'm not going to do this every single time, but I want to show you guys at least how I'm getting that number. It also helps to have a times table in front of you if that helps you. So if I divide out a 2, and I'll do this in a couple steps, I did the last one all at once. If I divide out a 2, and this process, by the way, when I divide everything by 2, I'm kind of trying to show you how that works. I'm not literally just dividing them by 2 because I'm basically undistributing that 2, so it has to go somewhere. So 6x divided by 2, that gives me 3x. Negative 4x squared divided by 2 gives me negative 2x squared. And 2x to the third divided by 2, those 2's divide out, so I'm left with x to the third. Now, I can still factor this further, and I could have done this all in one step, but I want to show you the differences here. If I have an x here, and I have 2x's here, or x squared here, and x to the third here, that means I can also divide an x out of all these things. So, if I pull an x out from each of these, so I'm going backwards with that distribution, that x is going to go out front. So I'm going to have the 2x. So if I look at that literally, those x's divide out, and I'm left with 3. One of those x's divides out, so I'm left with minus 2x. And then one of those x's divide out, and I'm left with x squared. So that is as factored as I can do for this particular time. We'll get to a place where we can start factoring further after that with polynomials, but today we're just focusing on greatest common factor and grouping. If I turn my paper over, actually, now I want to do one of the more variables. So now I have x's and I have y's. So what I want to look at is my greatest common factor between 27, 18, and 45. So I'm going to go ahead and factor all of those for the viewer's benefit, even if you might be bored to tears by this point. So 1 and 27. 27 is not divisible by 2, so I'm not going to list 2. 27 is divisible by 3. 27 divided by 3 is 9. Not divisible by 4, not divisible by 5, 6, 7, or 8, and then we're back to 9. 18, 1 and 18, 2 and 9, 3 and 6, not divisible by 4, not divisible by 5, and back to 6, so we know we have all our factors there. 1 and 45, not divisible by 2, 3 and 15, not divisible by 4, 5 and 9, not divisible by 6, 7, 8, and then we are back to 9. So my greatest common factor here, the biggest factor that I have in all three of these, is a 9. So I'm going to divide out a 9 and put that out front. Now I need to look at my x's. I have x squared, x, and x squared. So my x here, that's my highest exponent, x to the first, so I can divide out a single x. I have y to the third, y to the second, and y. So once again, I can only divide out one single y from all of those. I don't have enough to take out any more than that. So if I take 27 x squared y to the third and I divide out a 9xy, 27 divided by 9 gives me 3. X squared divided by x gives me x. Y to the third divided by y gives me y to the second. Bring down that minus. If I divide a 9, out of room on there, 9xy out of that one. 18 divided by 9 gives me 2. X divided by x gives me 1, so my x's are out of that one completely. And then y squared divided by y is just y. Bring down the plus. 45 divided by 9 is 5. X squared divided by x is x, and y divided by y is just 1. So that one divides out as well. So there is my greatest common factor factored out. Continuing on to grouping. You know what? This is already a 10-minute video, so I'm going to do a separate video to go to grouping. Enjoy that one. If I can get the video to stop. There we go.